So can you see my screen?
हाँ सर.
Okay, so we'll start a new topic in spatial database and modeling. We have already completed majority of our syllabi. Today we'll be treating and we'll be reading about your map server and geo server. So we'll see how, what is its functioning, what is its methodology, what is its application, its utility. So I'll start up with map server. So map server is an open source platform used for publishing spatial data and interactive map applications on the web. So nowadays we are very acquainted with the downloading of the data sets, downloading of satellite images, digital elevation models, or you're seeing the various space application center providing the various database related to cadastral system or forest information or land information. So map server were originally developed in the mid 1990s by the University of Minnesota for NET project in cooperation with NASA, and finally this now project is being shared by OSGeo, that is, and is maintained by a growing number of developers, nearly 20 from around the world. It is supported by a diverse group of organizations that fund enhancements and maintenance, and its administrators within OSGO by the Map Server Project Steering Committee made of developers and other contributors. So you can see that how initially it started from a project of a university, and gradually it is now a part of a open source geospatial community where it runs on all the major platforms, where you talk about Windows, you talk about Linux, you talk about Mac operating system Max. Map servers is not only featured GIS system, but it is also written in C language. So it's of great use to the developers, it gives use to the programmer. And what are the advantages of this map server features? That has got advanced cartographic output, that is scale dependent features, drawing and application execution. You can make the various kinds of drawing, anybody can draw from its home, and it can work on the data sets, and finally he can execute the data. Feature labeling, including labor collision meditation, so you can not only map that earth object, but you can also provide labels, color, symbology, scale, not orientation, then fully customizable template driven output. So you can customize, like if there are various clients to you and you want to get in a standardized data template, so you can customize those template and can be redistributed to various subletting organizations who are working in that project, so that each and every department who is working with you has got the same template, has got the same objective, has got the same methodology, has got the same identification techniques, so that there can be a uniformity in the data sets when it comes to your scale bar, reference map, legends, and finally thematic map boards. You can perform various kinds of themes based maps. So it helps to support popular scripting and development of environment. So each and every person who is working in PHP, Python, Perl, Ruby, Java, and .NET can work in this map server platform. Not only that, it's a cross platform support where you can work in Linux, Windows, Mac operating system, Solaris, and many more. It also support numerous open geospatial consortium standards like WMS client server, then non-transactional WFS client server, WMC, WCS filter encoding, SLD, GML, SOS. So multitude of raster and vector data formats like GeoTIFF, E3 Safe File, PostGIS, E3 ArcSD, Oracle SQL, MySQL, then various maps projection. So all the things that we know is possible to be performed using map server. So how it works, we'll be seeing its functionality. So it is most basic form. Map server is a CGI program that sits interactive on your web server. When a request is sent, the map server uses information passed into the URL and the map file to create an image on the requested map. The request made to return the image in the form of legend, the scale bar reference map values as CGI variable. So what you can do, you see there is a map request. So this request go to the web server. Web servers goes to the map server. Map server goes to the various kinds of application. The goes to the map file. Map file goes to the spatial database. Here all the GIS data processing related to your raster data, vector data are returned back to the map server. Map server returns to the web server, and web server returns to the map request user, and the user gets a map in the form of source he's for looking for, and finally you'll get a map in terms of various features with different scale bars reference. So this is the entire processing, that how it is connected, how the request is passed to the server, then server to the application to the geosite portal. So this is the basic architecture of the map server application. So you can see that their data storage, their web services. So data store comprises of your vector data, raster data, web services, WMS, WFS styles. They are the input data sets, and this all are compiled as a my map file configuration. My map file configuration is differentiated into two segments, that is map server CGI application and map script application. Then that is passed into Apache or IIS, and thereafter it is disseminated into various operating system like SWF file, SVG file, PDF file, HTML plus image file, WMS, WFS, WCS. They are the output forms through which you will be getting your results in the form of PDFs, JPG, TIFF, whatever you're looking for. So what is a my file? A map file is a structured text configuration file for your map server application. So for any configuration, for any map file, you must have some programming. And what it does, it defines the area of your map. It defines the area of your map, tells the map server program where the data and where to the output. So it locates the data and it provides the output in the form of images to the user for the data he is looking for. And it also defines your map layers, which are the map layers including the data source, projection, symbology. All the data sets are stored in those servers. And finally it must have a dot map extension of a map server will not recognize it. So how does this map server, what are the basics that are required for installation of this map server? That is, first you download the latest MS4W base package, then extract the file, route to one of the drive. Generally whenever this is a local operation that we generally do for any kind of installation, that goes to the C drive, then double click to the MS4 Apache install back to install and start the Apache web server. And in a web browser, go to http dot 127.0.0.1, and you should see that MS4 page is opening, and now you can start running your PHP script and Apache. You can also optionally install other applications that are pre-configured for MS4W, which are located on the MS4W download page. That is the basic MS4 package. Install a pre-configured web server environment that includes the following components, that is Apache HTTP server version 2.2.22, then PHP version 5.4.3, then map server CGI 6.03, map script 6.03, C sharp, Java, PHP, Python, include support for Oracle 11G and SD if you have associated clients or DLLs, MR SID support built-in, CDAL or OGR 1.9.1, and utilities, map server utilities, proj utilities, OWT chart 1.20 utility. So how you will be verifying the map server is working or not? So you see when you are installing it, you will be seeing that what is the map server location. If you run it, means don't query information to decode query string is set, but it's AMG. So you'll be finding the such kinds of information. And what you have to do, you have to add the map server. The vector forms are also enclosed in that. So what you have to do if you want to support the vector data, so map file is the heart of the map server, because all the server, all the operation, all the information is based on your file, is based on your file, and that are map files. So it defines the relationship between the object, between the point map servers to where the data are located, and defines how the things are to be done. The map file consists of map object, which has to start with the word map. There are some important concepts that must be understood before one can map files to configure map server. First is the concept of a layer. A layer is a combination of data plus styling. Data in the form of attribute plus geometry are given styling using class style directives. Map server map files uses the font sign to denote the start of a line comment. So this is the a simple map one program that will be running it. So we'll start map, then you will be writing the name of the map, then image type, the format of the image in which you are looking for, then the extension of the map, where to start, where to end, what is the minimum, what is the maximum, what is the size, the extent of map appearance in the form of pixels, then save path, the path of your folder of your system, then units, what units you are using it, then the layer, then the name of this layer, then the data, the name of SSP file in the data archive, then stated, should the map be turned on or by default, then type, is the data represented to be is a point line polygon feature, then what is the class, what is the style, what is the color of the element, and finally you've got a and program, and this layer is the layer would appear in the layer described above, and again you will be ending it. So this is the final output that you will be getting from the above command. So when you type hashtag, well, the entire map is on the map screen, so you'll get a map. The name of the map is my app. Extension, you have got the extension, what is the size, what is the shape path, what is the image type, there you're getting. Then again you need to at least one layer defined in your map for the display. So again you start off the layer definition, so you'll be getting the state polygon layers name, which this take, what are the data types, what are the line data, what are the status. Then again the stamp class object is defined with the layer object class, then the color code is assigned, then you will be ending the program, and then finally you will be testing the program in terms of .map file. So you can see this is the host through which you'll be checking your map server. This is the display, the data sets that will be generated, and this map server SSP IMG utility, you simply pass a map file to the executable and a name on the output image, and the image is generated. If there is a problem in the map file, SSP2 image will be the output, the line number in the map file that is crossing the treble. So to use this .bat file is used to be executed. So how you will be testing the .map file continued? So you will be using this map server open layer into the viewer. The map server provides a simple built-in method for testing a simple map using open layers. This features is for testing development purpose only and not for the production or deploying the full featured sites. You can preview, you can test, you can navigate a map file by accessing a special URL, which will in return a building open layer template. So such kind of templates will be generated. And in case you've got a map server, you want to add the raster diet, again you have to have a sample map file, that is map, name of the file, extension, unit, size, shape data, then the file name, its format, data type, status, and finally you'll be seeing such kinds of map in your screen. So using this Connections are found between the pre and post data sets where you'll be providing with a username and password, and that username and password will be used for the demarcation, for the recognition of the object, and finally such kind of user interface will be generated, and you can download the entire data sets of your interest using the WM server, using map server. So what you have to do, you have to install the required software. The WMS requests are handled. So WMS requests are handled by map server CJA program. So the first step is to take your map server executables includes WMS supports. One of the way to verify this is use the a command line switch and look for the support WMS server. So you can see that how you will be looking for the support in the WMS server and set up a map file for your WMS. For each instances of WMS server that you set up needs to have its own map profile. It is just a regular map server map file in which some parameters and some metadata entries are mandatory. Most of the metadata is required to be ordered to produce a valid get compatibilities output. Here is the list of parameters and metadata items that are usually optional with map server but are required or strongly recommend for WMS server. So what are those things? To set up a map file for WMS, you need at a map level map name, map projection, map metadata, map tiles, map online source, WMS projection. Then what are the kinds of layers? Its name, its projection, its metadata, tiles, layer status, what will be the default, whether it's on and off mode. All such operations will be defined. So using this map name and WS titles, the WMS capability requires a name and a title tag for each layer. The map name and WMS title metadata will be used to set the root layer's name and the title in the get captcha bulties XML output. The layer name and WMS title metadata for which every individual layer needs to have its own unique name and title. The layer name are used in get map and get feature info request to refer to layers that should be included in the map output in the query. Then you have got map projection and WMS SRS metadata, where WMS servers have to advertise the projection in which they are able to serve the data using EPSG projection codes. Then layer projection and WMS SRS metadata. By default, layers inheritance in the SRS of their parent layer. The map projection in the map server case. For this reason, it is not necessary to provide projection for every layer. Then you have got WMS online resource metadata, where the WMS online resource metadata is a set in the map object metadata and specifies the URL that should be used to access your server. This is required for get capabilities output. It is strongly recommended that you provide the WMS online resource metadata. Then you have got WMS enable request metadata that specify which requests to be enabled. This default data, the following list can be enabled like get capabilities, get map, get picture info, get legend graphics. It enables all the requests. Then finally, configuring to get features into the request, you must set the layer template parameters for the layer to be queryable to get features info request. For request of type text HTML, you should also set the layer header and footer parameters. Now you want to get QGIS map server export plugin. So what you have to do, you can use QGIS to compose your map by adding and arranging the layers, symbolizing them, customizing the color, and then creating a map file for the map server. So what you can do, you can use the map server export QGIS plugin to create a .map configuration file. You will first need to enable the plugin, which comes bundled as a part of the standard installation through the plugins menu. Then select manage plugins, then select map server export from the QGIS plugin manager. So what you have to do, you have to go into the QGIS, you have to select for the QGIS plugin, then you have to go for the map server export version 0.43. Once you will be selecting this, then this will be opened up. So under this you will be identifying the map file, then its name, its width, its location, URL, its symbol, its templates, its header file, its footer file, and finally all these sections related to your map section, projection system, output format, legend section, web section, map section are saved in plugin. And you have to set up a WMS server using map server. You have to write the name of the test WMS, status on size, extend, units, shape path, image color, then projection times, then you will be ending the program, then you will be providing the image path, image URL, metadata, WMS style, WMS RSS, WMS online services, then the server executive maps, the contact portion, the enable request, and finally you'll be getting the projection, its latitude, longitude, datum. So all such programs will have to be set up in your program server through WMS server using map server. And finally, you will be getting the image type as PNG, output format, the name of the PNG, then the driver, then the image type, what is the minimum type, then image mode, then transparent extension, the name, status, type of data, data with the type, what is the projection, metadata, then again WSRMS, WSL tile. So once you have to do, you have to test the WMS server and post you're running that program, you'll be seeing such data sets to be are added in your data sets, and you can act on those data sets. So setting up a WFMS server using map server, or WFS, a web feature services publishes feature level geospatial data on the web. This means that instead of returning an image, the client now obtains fine-grained information about specific geospatial features of the underlying data at both geometry and attribute level. As with the other OGC specification, this interfaces uses XML over HTTP as its delivery mechanism, and it's more precisely GML, that is geographical markup language, which is a subset of XML. So what you have to do, we have to do the configuration of map file to server WFS layer. So much as in the WMS support, WFS publishing is enabled by adding certain magic metadata keywords, value pairs to a map file. So data source is of vector file, so you'll be finding the save file or OGR or PostGI or SD. Then the layer name must be set, layer type must be set, whether you are looking for a line, polygon, or a point feature data set. Then WFS Online Metadata. WFS Online Metadata is the set of map web object metadata and specifies the URL that should be used to access your server. And the WFS enable request metadata, and this required for get capabilities output. And finally, you're setting up a map server side, we are installing it, you're building from the source code, installing a package, get a data on the server, create a map file, and choose or write a front end program. This is all about what till now we have done with the map server. Now we'll be going with the Geo server, how the map server and the Geo server are connected to each other. So what is Geo server? So Geo Server is Java-based platform, independent server-side software. What it does, it takes your data and publish it on a network with a variety of protocols. So at last, we are all reading such materials or such topics because we want to create, we want to have a web server. So with a strong emphasis on OGC standard, that is WMS, WFC, and WCS, both with an extension for mass market one, that is Google Earth, GeoRSS, GeoJSON. So Geo server reads a variety of data sets, just like the other services map server. It also read various variety of data formats, that is PostGIS, Oracle Spatial, ArcST, database, MySQL, Shapefile, GeoTIFF, GTopo 30, ECW, MRSID, JPG. So through these standard protocols, it produces KML file, GML file, shape file, GeoRSS, PDF, GeoJSON, JPG, GIF, SWG, PNG, and many more. In addition, one can edit the data using WFS transitional profile. GeoServer includes an integrated open layer client for previewing the data sets. Not only that, it uses the different kinds of style layer descriptor, that is also known as SLD, that uses an XAML documents for deriving the map generation, which also allows for attribute and scale dependent styling. Then SLD file creation that uses GeoServer, that has a very simple style generator, then uses UDIG or GVSIG to generate SLD files, and no easy to use editor with the full support for SLD style. So this is how we'll be installing the GeoServer 2.2.4 setup. You'll be installing it. You go to the install options. When your GeoServer will be installed in your system, then you can click finish to get it installed. So if you install GeoServer as a services, it will be already running. Otherwise, you can start GeoServer by going to the start menu, and start GeoServer in GeoServer folder. Navigate to server URL port GeoServer example http://8080/0 server to access the GeoServer web administration interface. If you see GeoServer in your browser, GeoServer is successfully installed. The web administrative tool is a web-based application used to configure all aspects of GeoServer, from adding and publishing the data to changing servers settings. So you can see how it look like. What are the different kinds of Geo server belongs to which department, Geo server, what are the various kinds of WCS, WFS, WMS, TMS, WMSC, WMTIs. So this is the Geo web Geo Server Web Administrative Interface. So when you will be getting opening it, you will be seeing such kind of interface when you will be opening it. So you have got the various data file formats. On the left hand side, you will be seeing the server status, then Geo server logs, what are the contact information about the server, the layers per view is there, workspace is there, storage is there, the you can have various kinds of layouts, you can group them, you can have various kinds of styles, then various kinds of services you have, that is WCS, WFS, WMS. Then you can have settings, that is global, JI, coverage assess, then catch, title layouts, catching defaults, grid sets. Then you've got security features, then you've got a preview functions where it provides you open layer KML file where you can simply axe the grid, you can mosaic, you can have a distance, a layer boundary, then you have got different archaeological sites, then restricted area, roads, streams, geographical informations, all such operation informations can be used, can be obtained using your GeoServer. So GeoServer publishing save file will be using nigroad.zp file that comes with the GeoServer documentation. This archive contains a shape file of roads for the New York City. So unzip this road.zip. The extracted folder nyc.road contains the following four files, that is nycroad.ssp, nycroad.shx, then .dbf, then .prg. So move the nyc road folders to GeoServer data, where GeoServer data directory is the root of GeoServer data directory. So once you have done, we'll be creating a new workspace. A workspace is a container used to group similar layers together. So you will be prompted to enter to a workspace name and namespace URI. So enter the name as NRIC road and the namespace URI as HTTP localhost oblique NYC doc road. A workspace name is a identifier describing your project. It must not extend 10 characters or contain spaces. A namespace URI, Uniform Resource Identifier, is typically a URL associated with your project. Perhaps and added trailing identifier indicating the workspace. Click the submit button and the NYC under roads workspace will be added to your workspace list. So now you can see that you have created a workspace, you have created the name, you have provided the namespace URI, and once you will be providing this, you'll be getting a space. Then once you have created a space, you have to create a data source. Then go to the data source. In order to add NYC road save file, you need to create a new storage. So for creating a new storage, click to the add new store button and you will be redirected to a list of data resources supported by Jio Server. So you can see that, go to new data source where vector data source, what is the directory, post yes, database, Qgis, properties, shapefile, web features, then raster data source. You've got grid, you've got GeoTIFF, Topo, GW30, then image mosaic, world images, other data set, WMS. All the data sets are available, and here you have to go and you have to add your data set. Once you have added the data set, select the files shapefile dot ESHRI shapefile. The new vector data sets will be displayed, and begin by configuring the basic store info. Select the workspace NYC oblique road from the drop down button. Enter the data source name as NYC roads and enter a brief discussion such as roads in the network city, New York City. Under connection parameters, specify the URL of the save files like data oblique NYC underscore roads oblique NYC under roads dot SSP. Click save and you will be redirected to the new layer, choosing the pages in order to configure the NYC roads layer. So you see on the right hand side the new water storage. You have to here highlight the ESRI TM shape files. Then you have to provide the basic info related to the workspace. You have to provide the name of the workspace that we have created earlier. Then you have to provide the data source name. What is the data source name from where you are getting? Then a description about the product. What is the description? So you'll be writing right now what exercise we are doing is related to the roads in any particular city. Then you have to provide the URL, then you have to specify the namespace, then you have to provide the chart set. All such thing has to be provided. Then you'll be creating layer, how to create a layer. So on the new layer chooser page, select the layer NYC road. Then the edit layer page defines the data and publishing parameters for a layer. Enter a short title and an abstract for NYC underscore layer. Generate the layers boundary boxes by clicking the compute from the data and then compute from the native boundary. So what you have to do, you have to provide the native x, minimum x, minimum y, maximum x, maximum y in both the latitude and the longitude front. Then you have to set the layer style by switching to the publishing tab. Then select the line style from the default style drop down list and finalize the data configuration by scrolling to the bottom of the page and clicking save. So on the right hand side, you can see this is the space that we have created. Then go to the option publishing, then go to edit data, then you edit the data, you see the layer name, then you allow the advertisement, you enable then HTTP settings. You have to provide the cache time, then you have to provide the WFS setting, what is the pre-request feature limits, what are the maximum number of downloads, then the WMS sentence, what is the default style. All such features, all such properties has to be handled, has to be sent to the server. And finally you'll be previewing the later layers. In order to verify that NYC layer is published correctly, you can preview the later layer. You go to navigate to layer preview screen and find the NYC underscore roads dot NYC underscore layer. Click onto the open layer link in the command format for common format column, and open layer map loads in a new page and displays the shapefile data with the default line style. You can preview map to zoom and pan around with the data sets as well as display the attribute feature. So what you can do, you can go and you can see the what are the layers that has been has been added. You can preview, you can download, you can see all the kinds of data sets. You can see the data sets related to your sample size has been uploaded, your to image file has been uploaded, mosaic has been uploaded, to subset it has been uploaded, HTML file, and you can preview, you can have a scaling, you can have overview of the entire data sets that you have uploaded. And finally, Geo Server for publishing a PostGIS tables. The data sets of the building from the New York is stored in a PostGIS database being used as nyc/building.zip. Create a data store. And the first step is used to create a data storage for the PostGIS as nyc underscore. The data so tells the Geo server how to connect to the data set, like in a web browser, navigate to the local server, then navigate the data to the store, then create the new data by clicking the PostGIS link, erase the basic store information, keep the default workscape, enter the data source name as nyc underscore building, and a brief discussion, and finally specify the PostGIS database connection parameters and you save it. It is the same operation how we did in our earlier exercise. You will be using the PostGIS database. You have to specify the workspace, then the data source name, then the connection, the host, the port, the database, the schema, the user, the password, all the things are specified. And finally, you can edit the layer page, which defines the data and publishing parameters for a layer. Enter a salt, title, and abstract for the building as we have done earlier. Generate the layers boundary boxes by clicking the compute from the data and then compute from the native bounds. Set the layer styles by switching the publishing tag. Select the polygon tag from the default style drop down list. Finalize the layer configuration by scrolling the button to the page and clicking it down, and then you can preview the layer. So you can see that in order to verify the buildings layer to be published correctly, you can preview the layer, navigate the layer preview screen, and find the nyc.nys.layer. So you will be seeing the layer key where it is the layer, and click the open layer link to the common formats column. So when you will be clicking it, you will be seeing your screen in such format where you have all the scale, all the x and y, then Latin magnitude. So working with the data, the raster data sets related to GeoServer, whatever example what you have seen right now was related to your vector file. Now we'll be seeing the working space with the raster file. That is the standard GeoServer installation, supports the loading and serving of the polling formats like GeoTIFF, G Topo 30, world images, image mosaic, and other data sources which are supplied as GeoServer extension. Extensions are downloadable models that can functionality to the GeoServer. Extensions are available in GeoServer download page. Adding the GeoTIFF data storage. GeoTIFF is a georeference TIFF tagged image file. So raster dataset GeoTIFF, that is the tagged image file. So go to the add raster, go for the description GeoTIFF, then you go for the workspace, then the data source, then provides the description, then provide the URL, and then just save it. Now all this geo server will be based into the web services. So all the geo service saves the data using a standardized protocol established by Open Geospatial Consortium, where the web feature services supports request for geographical feature data with vector, geometry, and attribute. The web map services supports request for map images and other formats generated from geographical data. The web coverage services supports request for coverage data that is raster, and these services are the primary way that the geo server supplies the geospatial information. So WFS, the get capability operation, is a request to a GFS servers for the list of operation and services or capabilities supported by that service. To issue a GET request using HTTP, the following capabilities or program has to be run, where you will be providing the description feature file which suggests about the request information about an individual feature type before requesting the actual data. Specifically, the operation will request a list of feature and attribute for giving the feature data type, data availability, and we'll be going to return to a list of feature type. This is the command. This is the information that you have to generate the get feature. Operation returns to a selection of features from the data source. This request will be executed to get a get feature request from a given layer name feature data set. So all those information can be get through this geo server. Then WMS, the OGC Web Map Services specification defines an HTTP interface for requesting georeferenced map images from a server. Geo server support WMS 1.1.1, then the most usually version of WMS as well as WMS 1.3.0, where the get capabilities helps us to retrieve the metadata about the services, including supported operations and parameter and a list of available data. Get map retrieves a map image for the specified area and content. Get feature info, that is optional, retrieves the underlying data, including geometry and attribute data for a pixel location of a map. Describe layer is again optional, indicates the Wfms or WCS to retrieve additional information about the layer. Get lesion graphics helps you to retrieve generated lesions for a map, and this is the get facility request. This is the browser, and this is how you will be getting the accessing the Geo server using the WMS services using Qgis. You'll be running this plugins and the images. You'll be getting those all informations into the your Qgis platforms, and this is how we work on the various applications of Geo services, Geo server. So when you want to work in the QGIS platform and you want to get many of the satellite images like Google Earth and various OpenStreet layers directly to your image or your display or your interactive screen. So you will be using such commands, WFS, WFC commands to get those. So these three are very important services that each and every person must be trained of, must be knowing of, because many times when you're working in the remote sensing and GIS discipline, you have to work on various kinds of raster data sets. So for getting the raster data sets, you will have to use the web coverage services, and for getting the various kinds of map services on your images, you will be using the web map services. And when it comes to the vector files, you have to use the web feature services, and those all support system has to be used in order to get the information for which you are interested in. So it all depends on your objective, for what kind of studies you are looking in, for what kind of data you are interested in. So you can see that this web based geo services has got a great services, the great support from Open Geospatial Consortium, where the eminent scientists, where the eminent researcher daily update the program scripts, the database are updated, additional data are being added to the existing data sets. And when you're performing and we are interested in to do a world level study or an India level study where you're wanting a high resolution satellite data, which is very costly in nature, but when you will be using such kind of services, you can obtain a very high resolution as a background image with no cost. And that is all possible because of the Open Spatial Geospatial Consortium, which provides you various kinds of services like web coverage services, web map services, web feature services, which helps the user like us who uses all those vector files, all those rasters files for various kinds of research, whether we are looking for research into the hydrology, whether we are looking for cadastral level mapping, whether you're looking for urbanization, whether you are looking for high resolution horticultural mapping, site suitability and analysis. Whatever comes to your mind, the geo services, the geo map services provides us great help to the scientific community, and it's of great use to the world. and you can see that nowadays the proprietary softwares like Qgis has got a tremendous competition with the Qgis because of its capacity, whether in terms of you say to the map server, whether it comes to the vector server, whether it comes to the coverage files, all such operations can be performed using this map and geo server. And with this, I think that most of your questionnaire that was related to the map server, geo server, its functionalities, its applications, its utility, its command, its script, its writing, its location, data sets, how the data has to be projected, how the data has to be written on the web platform, how the data has to be sourced, how it will be uploaded in your QGIS network, how you will be interacting with the data sets, how you will be securing with the data sets, can be easily monitored, can be easily modeled using the map and geo web surface services. So nowadays, that's why many scientists, many space agricultural space ISRO is prominently suggesting the users like us, the teachers, to train the students in QGIS because of these services. So with this, I'll end to my today's discussion on Geo server and Map server, and then we'll have about 10 minutes of discussion related to whatever doubts that you have in your classes, and thereafter a quiz in your LMS. And with this, I'll end my today's presentation of GeoServer and map services.